Okay, so we got our answer here. Now we're going to check to make sure our answer makes sense when we look at the questions. So, if the coefficient of friction is equal to 0, that means there's no friction. If there's no friction, then is the car going to stop? Probably not. So if there's no friction, what should t equal? Well, that would equal infinity. Does your function agree with this observation? If u is equal to 0, no it doesn't, because if this term is equal to 0, what I end up with is v divided by negative g sine theta. So my function says that v is negative. So no, my function doesn't agree, but neither does my function give me an answer that I believe. So let's continue and look at the next question. If the mass is doubled, what will happen to capital T? Well, the mass canceled out, so nothing happens to the time. So the time it takes to stop does not depend on the mass. If V is doubled, what happens to T? Well, V is in the numerator, and that's the only place it appears. If you double the V, T is going to double. Is there a maximum angle above which the car will not stop? If so, determine an expression for this angle. Okay, so now it comes time to look at what we have in the numerator. I know if I'm on a horizontal surface, I'm not going to have any trouble stopping, but if I make the angle 90 degrees, that's not going to work out very well. So there must be some angle at which I'm not able to stop. Look at what we have in the numerator here. We saw before that if the coefficient of friction is equal to 0, we get an infinite time, but our function gives us something negative, which we don't want. So we're going to look at what happens to the numerator if mu kg cosine theta is equal to g sine theta. Then you get 0 in the denominator, you get 0, which means t is infinite. That means you can't stop if you get an infinite time. So if mu k g cosine theta is equal to g sine theta, that means mu k g cosine theta is not greater than g sine theta, which we said is what we wanted here. So if this is true, that's when t goes to infinity. And we were looking for the maximum angle here, so we want to solve this for the angle. So g is on both sides, that cancels out. Divide by cosine theta, and you get mu k is equal to sine theta divided by cosine theta, that's tangent theta, and you can take the inverse tangent, and this is when we have the inverse tangent of mu k. And this would be the maximum angle above which the car will not stop. And if theta is any greater than this maximum angle here, then you end up with something negative like we got in question 1. So we should be able to stop if we're on a horizontal surface, right? But if there's no friction, even when the angle is 0, you can't stop, because what is the inverse tangent of 0? That gives you 0. So if the coefficient of friction is 0, the maximum angle above which the car will not stop is 0. We needed this term to be greater than this term, so it's not greater, they're equal, and so even when your angle is 0, if your coefficient of friction is 0, you're not going to be able to stop. That's what happened in our first question here.